Hello, everyone. How's everyone doing? Welcome to the last afternoon of SREcon. So you might have heard this talk, and you might think the title of this talk, Whispers in Chaos. What is he talking about? Well, chaos, what does that mean? Well, we're going to be talking about incidents. So I want to actually start off. This is a tried and true like post-lunch presentation technique. I want to do a little survey. So raise your hand and keep them up if this applies to you. Raise your hand if you're an SRE and you work incidents. Okay, that's a good showing. Okay, keep them up. And then raise your hand if you're like a developer or someone else who gets pulled into working incidents. And raise your hand if you're neither of those, but you just want to know when the damn website's going to be back up. And that's pretty much everyone in the room. So I think you're in the right place if we're talking about incidents. So another quick question. How do you know an incident is occurring? Shout it out. How do you know an incident is occurring? You get paged. Alerting, right? Monitoring, alerting, right? That's not a trick question. I hear somebody in the back going, hey, Lisp, you know an incident is happening because of Lisp. No, monitoring. So, but there's an interesting question about how do you know what to do when an incident is occurring? And that's what we're going to be exploring a little bit today. So, there are a lot of details about me on this slide. I'm not going to go through them all. I'm going to go through a couple, though. I'm J. Paul Reed on Twitter. So if you have to say something in this talk that you find interesting or have a question or whatever and we don't get to talk about it, you can tweet me at J. Paul Reed. The other thing that I would point out, I'm a Master's of Science candidate in Human Factors and System Safety. And the reason that I bring that up is a lot of the things that we're going to be talking about in this presentation actually have to do with research in the safety sciences in the past 80 or so years. So you'll see that kind of thematically again. The other thing I'd actually point out is my background is actually build and release engineering. So this is my first SREcon, and I've noticed kind of a theme about SREcon presentations is you have to define what SRE is. So this is my definition of SRE, super release engineer. So I'm SRE, or not SRE. So back to our question. How do you know what to do when an incident is occurring? Well, the first part to sort of thinking about this problem is to sort of take a look at the way our brains work. And there's been a couple of ways, lots of different ways actually, that science and researchers have kind of looked at, okay, how do our brains parse information? How do we react to situations? And one of those sort of models for it is sort of what they call the brain systems, or two types of brain system. They call it System 1, and that's the part of our brain that's very automatic and quick. It's little to no effort for us to use it. And there's often not really a sense of voluntary control, right? We kind of will just react very quickly. And it doesn't take a lot of cognitive processing to do this. Of course, the other one is System 2. They often describe it as effortful. So we use this in complex computations. This is a lot of times, when we're working on a problem and we feel tired at the end of the day, like we're solving some particular coding problem or something like that, and we're tired at the end of the day. That's because we're using sort of System 2. I like this quote. It's associated with agency, choice, and concentration, right? So if this sounds familiar, a lot of this comes from Thinking Fast and Slow by Daniel Kahneman. He won the Nobel Prize for economics, actually. So talking about like humans in economic systems think about problems. This is a pretty chunky book because it covers a lot of his work. So examples of System 1 and System 2 problems, right? Orienting to the sound of a sudden source. So if somebody drops a book or a firecracker goes off, our ability to like find where that sound is coming from and look at it, System 1. 2 plus 2, you probably answered that in your head without as soon as I said it, right? Finding a strong move in the game of chess. We're going to come back to this only if you're a chess master. We're going to come back to that because that turns out it's interesting that that's System 1, and there's a reason we'll come back to that why you would think that would take a lot of concentration, so it'd be System 2. System 2 things, it's coming up on tax time, so filling out a tax form. Focusing on a particular voice in a crowded room. Checking the validity of a complex logical argument. And the key point here is System 2 requires our effortful attention to process, and more notably, when we get distracted. And you've probably had this, maybe in a crowded restaurant, you're trying to listen to to what somebody's saying, and then something happens, and then suddenly you lose track of the conversation. You lose track of what they're saying. It takes, when we're disrupted, attention is taken away from that. But as most things in cognitive psychology, it's more complicated than that. And so there's more research to sort of look at in terms of what we do in a particular context in our jobs in incidents. So many of you might know this gentleman. This is John Allspaw. He was the CTO of Etsy. He was also one of the program co-chairs for the Velocity Conference for a number of years. And he did a bunch of research related in sort of our domain of SRE and operations and DevOps on exactly this question. So this is his thesis, the title, Trade-offs Under Pressure, Heuristics and Observations of Teams Resolving Internet Service Outages. So we're going to look at some of his findings when he basically sort of went into the laboratory, and it's kind of interesting, the laboratory was Etsy, and looked at what SRE engineers there do in the context of solving an incident. So what was the incident? Well, during the busy Cyber Monday, Cyber Holiday shopping season in 2014, it was reported at 1:06 p.m. Eastern that the personalized homepage for logged-in users was experiencing loading issues. So that's the incident that we're going to be looking at. So if you've ever done postmortems or retrospectives, you're probably familiar with the whole, hey, let's do a timeline thing. This is straight out of Sidney Decker's book. It's a picture of kind of how he describes a timeline. One of the interesting things, I've seen a lot of timelines in the research that I've done, a lot of organizational timelines from incidents. One of the things I point out that's interesting about Decker's model is that it has three separate components to it. The sort of system data, so that's the graphs you see on top, the tasks and actions that different actors took, and that's in the middle, and then of course what they said is on the bottom. So he actually says you can have kind of different qualities of timeline and different depths of information that you could put on one timeline, and so he puts all of those on this. It's interesting to sort of consider in our context. We don't tend to do this very often. We don't, when we make a timeline, it's usually not as detailed as this. So that's, of course, when John was studying this, one of the first things he did. This is a sample timeline from the research he did. This is for a single engineer, so we can zoom in a little bit on this, and you'll see that these are different activities that they were doing, diagnostic activity, dashboard access. And one of the interesting things about his research is he had the ability to look at website access logs so he could see, they also use IRC heavily at Etsy, so he could correlate what were people talking about on IRC, and then what internal websites were they accessing. Were they accessing the deployment tool? Were they accessing one of the ones, actually it is their staff directory? Were they accessing the staff directory because they were trying to find another engineer to ask a question to? So he had this sort of wealth of data, and he from this one particular incident, and he was able to compose a timeline for each engineer that had, and you can see those kind of lines there that show when a particular activity happened. And he was able to sort of, on the bottom there you see, he talks about episodes, or kind of what Decker calls capital E events. So they're pivot points in the incident that are important and notable. And you can sort of start to get that when you see all of that data together and line it up. In fact, I'll just go back. You see those vertical lines. Those are kind of those capital E events in an incident. So he was able to do that here, and that's what those vertical lines are as well. So of course, software is a team sport. He was also able to look, these are combined IRC utterances in the research speak. So this is just a timeline of when did somebody say something, who are they, and when did they say something on IRC. So we can zoom in a little bit, and you can see that he looked at a bunch, he had infrastructure engineers involved, production engineers involved. So a number of different roles represented in this research in the incident as well. I put in here infrastructure engineer 1 and 2. I'm going to name them Alice and Bob. We're going to come back to why, but if you hear me refer to Alice and Bob again, I'm referring to infrastructure engineer 1 and 2. I gave them personas because it's a little easier to talk about. So what did he find? What did John Allspaw find? He identified 3 monitors or heuristics that engineers use to work incidents. So we're going to go through those, and I want you to think about, do any of these resonate with your own experience in working incidents? Because most of the room networks incidents. So heuristic number 1, change. Did anybody change anything? When you've worked an incident, has anyone done the cubicle thing where they pop out of the cubicle and they basically scream that to the rest of the floor? Has anybody changed anything, right? Was there a deployment push? Was there a network configuration push? Did somebody check code into GitHub? That sort of thing. So that's one of the first things that he found that engineers do in an incident. What changed? Now, the interesting thing about this particular incident is they all did that. They asked what changed. They looked at the tools. Nobody had done a deployment. Nobody had checked code in. Nothing had been pushed. There was no network or infrastructure config changes. So the answer for this first heuristic was no, nothing had changed. Okay, well, what do engineers do if that first heuristic, which if you think about it, at least in my experience and probably yours as well, most of the time something has changed, and this is a good first kind of solution for or question for us to ask, and it usually yields a pretty good solution. But if it doesn't, what do we do then? Heuristic number 2, going wide. So this is the idea that when we don't have a clear answer, we don't have what we might think of as a cause, this change that occurred, and we can't identify that. What we end up doing is using a searching technique where we look at our universe and we kind of go wide into all of the possibilities that it could be. And the technique that we tend to actually use is this going very wide, and then once we find something that it might be, we then actually go very deep. So it's this process of going depth first, very deep into, let me check on the caching servers, or let me check on the database servers, or whatever it might be, or maybe even some aspect of the database, right? And as soon as we find that's not the problem, then we go back to, okay, what in the realm of the universe of the system that I operate would I think could have caused this problem? But you might ask yourself, well, how do you make that switch between breadth and depth? And that actually plays into the third heuristic he found, which he called convergent searching. So again, this is the idea, like how do we as SREs, if we're going very deep and then we're going very wide, how do we know when to switch? And he found sort of an interesting pattern in the conversations and interviews that he had with the SREs about how they make that decision to switch. He found that basically they use two sort of sub-heuristics, a specific and past diagnosis of a problem, or a general but recent diagnosis. So what does this actually mean in practice? Well, in practice it means a really, really painful incident and memory of an incident. These are the things that stick with us throughout our entire career. They're the things that we tell stories about. And they leave such a mark on us that oftentimes we will go back and use that as a specific past incident to start investigating. The other one he found is generalized incidents, but in the past month to 2 months, right? So an example of this might be is if you're, as an organization, having continual problems with maybe your CDN, and you keep having outages, and when you run it down, it turns out to be the CDN. One of the things that you will go to go very deep is, I'm just going to look at the CDN first, because I know we're having problems right now with the CDN. So one of the other interesting parts about Heuristic 3 is that it's used to both confirm and disqualify. So we're looking for things where you can say, yep, that's it, so I should keep going down that deep path, or disqualify that as a branch of the tree of debugging that I need to look at. And so I can basically pop back up to the sort of, okay, I'm going to look at the universe level of things again and try to think about what it could be, and I'm going to use either something specific or some other thing in my sort of L1 cache in the system. So let's talk a little bit about the incident. So the real problem here, and this is a screenshot kind of the page that was having problems. The problem was this page was loading very slowly during a very high traffic time, so it was causing a lot of timeouts and issues for customers. It was caused by CDN cache misses due to a HTTP 400 status in a particular API from what they call a closed store. So they have different Etsy stores, and stores have state, so you can close a store if a store actually closes, or if it's shut down because they didn't pay their bill or whatever it might be, right? So this is a HTTP 400 from a closed store, referenced by a blog post in the sidebar. And you can see at the bottom there where it says more from the blog, that was the blog post that got referenced. So what's interesting here, what basically had happened is a Etsy employee who used to have a store but was now closed did a blog post. And that blog post got pulled into the web page, and the API was making a call. And because the call was failing, it wasn't caching any of the page. And then you have the performance degradation, right? But there was no change in terms of common things that they think about, that we think about as SREs, as being a change, like a deployment or a commit or a infrastructure configuration change. Now, one of the other things that was fairly interesting about the research that John did is he used a technique called process tracing to sort of figure out and map out for us what engineers were thinking about at the time. So I'm going to zoom in on this a little bit, and you'll notice he talks about there's both hypotheses and then actions, right? So circles and the squares are hypotheses versus actions. And so this is it's a somewhat crude way, because it's hard to sort of capture our cognitive state, but it's a way to show kind of, okay, based on the incident itself and the interviews that I had with the people, what were they thinking, and then what did they do? And this is what this is showing. Now, I want to bring up a couple of really interesting examples, and these are examples of the heuristics I was talking about before. If you look at Bob, infrastructure engineer number 2, he asks fairly early in the incident, is it a frozen shop? And it turns out that nobody else is on that page with Bob until later in the incident. Everybody else is looking at other things and chasing down other things. Bob asks fairly early, is sort of ignored. Bob chases this down, and then it turns out that it is a frozen shop. And then you see that other engineers come in and start asking about questions about shops. Not that they're frozen, because there's a question in there about, is it a featured staff shop, right? So what's interesting about this is an example, when he talked to that particular engineer, of a specific thing that was very painful, because this engineer, who I think had been at Etsy for about 3 or 4 years now, when they started, there was a horrible, horrible outage involving a frozen shop. So in their context of working at Etsy, one of the first things they always asked if there was an outage, does it have to do with a shop status? Is it frozen? They would constantly ask that question. So that's one example of that heuristic that I was talking about. The other example, Alice, varnish queuing, asked a question about varnish queuing. It turns out that in the past 4 to 6 weeks, Etsy had a lot of problems with their varnish servers. And so one of the really interesting things about when John went back to interview Alice is that he sat down in a structured interview format and he said, do you remember the incident on December 4th? And Alice said, yeah, I do. And he asked her to describe the incident. She started talking about another incident involving varnish caches, but it wasn't this incident that he was researching, and this incident had nothing to do with varnish caches. So that's an example of, in our recent L1 cache, that was so prominent in her memory that all of the incidents got kind of colored with this. I think it's a varnish. Could it be a varnish cache issue? It might be a varnish cache issue, right? And we've all had this, where there's some part of our infrastructure is sort of unstable, so we kind of like that's kind of a flaky part of our whatever, and we always think if it's an outage we might go there, and then as we shore up that system and have less problems with it, we may not ask that question as much because it's not in our L1 cache. So there's a bonus heuristic he found about testing the fix. So I want to do another quick survey. Raise your hand if, as a rule, when you do a deployment, you wait for unit tests. When a commit or a release comes in, you wait for the testing and the unit tests to complete before you deploy. All right. Now, imagine if you were in the middle of an incident and you made a one-line change to a config and had it reviewed by a colleague, and there's a lot of pressure to push the fix out. Raise your hand if you would still wait for all the unit tests to complete. Now, what's interesting is that's a lot less hands. If it's a rule, all of you should have raised your hand again. Now, John sort of found this out too when he asked this, right? You have the question about would engineers wait, and you have this sort of if the number 5 is yes, I would always wait if I was in this situation, and then 1 is I would never wait under any situation. And you'll notice again, there's a heuristic that we all use. We saw it in the room just now with that survey, where under certain contexts, we actually use our own heuristic about when to do this. By the way, the thing I love about this survey, there's this person that ops engineer, it's like YOLO, whatever, I will never wait for tests. It's fine. Ship it. So the next question is, how do you get better at detecting an incident is occurring, right? That is really kind of the question that brings us to events like SREcon, and that we discuss in the hallway track, and that we're trying to find out, like, how do we get better at this? So any thoughts? Any ideas? Well, monitoring things better, right? This is still not a trick question. Somebody's saying, like, let's use containers. No. But then the question is, how do we get better at knowing what to do? Right? This is the sticky, messy human part. How do we get better at knowing what to do in the context of an incident? Well, it's interesting to talk about this idea of experts. We are experts, expertise, right? Elements of expertise. This is from a paper by a couple of researchers called Hoffman and Klein. And they were trying to define, like, what does expertise mean in a particular context? How would we describe it? How would you know it when you see it? Well, we went to define it, right? And so they described this as experts using their knowledge base to recognize typicality, so they understand what a typical situation looks like. They're able to make fine discriminations, so that means that when they're looking at a situation, their ability to notice differences is much finer than someone who might be a novice is, right? They can understand subtle differences. I am not an artist at all, but this sort of thing where you can, or a singer either, but people say you're off pitch or that color doesn't quite match, right? Those are experts in those fields. They can do that, and I'm not, so I can't, right? They can also use mental simulation. This is particularly interesting. It's the idea that the research, they talk about firefighters. Firefighters can roll up to a scene and look at a building, and they can sort of simulate, okay, how are all the ways in my experience that got us to this point in the fire, and then also how can I see all the ways that this might play out? So they can do these simulations very quickly, and it gives them options to use when they're actually solving the problem. The other thing, knowledge base is also used to apply higher level rules. So in other words, they use all of these techniques and their knowledge base to basically apply higher order, higher level rules. So these are things, you just did it. I said, who has a rule that you let the unit tests finish before deploy? But when I said, okay, it's a one-line config change, you had your best friend on the team review it, and it's an emergency situation, you changed your heuristic around that. And that's because you basically know the rule when it's okay to break the rule, right? This is one of the differences between novices. The problem is with someone who's a novice in a particular field is that they will try to apply these higher order rules, and the outcome won't be good. And the problem is it's because they don't have enough knowledge base yet. So they don't have enough wealth of knowledge to be able to apply the higher order rule correctly, so the outcome is bad. And that's one of the distinctions they make between an expert and a novice. So you put all this together and you get this idea of seeing the invisible. With experience, a person gains the ability to visualize how a situation develops, so that's that mental simulation, and imagine how it's going to turn out. Experts are able to see what's not there. They're able to see in a situation, that this is interesting. Normally, when everything is fine, that's working, and now it's not here. And oftentimes, these are things that are feelings, right? Have you ever walked into a war room for an incident, and you're just listening to things, and then you come up with this idea that nobody thought to check, and it's just because you're walking into it fresh, and you're kind of like noticing what's kind of missing from the situation, and it might be the problem? That's what they're referring to here. So how can you promote this sort of useful experience to talk about? How can you build that knowledge base? There's a couple ways. The 10,000 hour rule. This was popularized in Malcolm Gladwell's Outliers. Now, I know someone's probably going to say, yeah, but Malcolm Gladwell, he likes to take research and add a story, and it's totally awful. I went, and by the way, I enjoy reading Malcolm Gladwell, but it's a valid critique. I went and read the study that he based this on, and this is a researcher in 1993, Anders Ericsson, talked about this idea of expert performance. This is the study that Gladwell took it from. And by the way, Gladwell sort of pissed this researcher off because in 2013, he wrote a paper explaining all of the critiques that Gladwell got a bunch of critiques, and people started critiquing his research, and he was like, no, Gladwell took it out of context. Here's my published paper on why. So he sort of responded to those. But what's interesting about his research is he was trying to figure out, for things that we think there might be a predisposition to, for things like music and sports, what makes pro sports players and symphony musicians really good at this. And he studied over time, it's this idea that it's effortful, concentrated practice. He called, or others have called it flow. So it's this idea, have you ever been in a situation where you're coding and everything's just clicking and you're in flow, and then somebody, of course, comes and bothers you and you're like, great, thanks, you've ruined my concentration. But that's what he was talking about. Over a number of years, when you can get into that state and learn that, that's what gives you this beginning of ability to see fine discriminations and look at situations and kind of play them out in your head. One of the critiques that he pointed out, and you have to be careful about, these are relatively stable systems. So it's music, it's chess, it's sports of some type, football, tennis, whatever, right? The rules for those things don't change too much, right? So a lot of this research applies to sort of relatively stable systems. And so it's an interesting thing about, okay, how does this apply to us? Do we work in relatively stable systems? By the way, as a point, this is why chess becomes, if you're a chess grandmaster, that's why the skill becomes system one thinking. They can look at a board and come up with a really strong move, and it's almost automatic. It's because of this 10,000 hour effortful practice. So what does expertise look like in other crafts? Well, so this is Captain Sullenberger, Miracle on the Hudson. If you look at that particular incident, one of the things that he did, and we see expertise in a number of areas of his behavior, he immediately started something called the APU. Now, when they went back and asked, so they hit birds, started the APU. When they went back and talked to him about this, that's not on the checklist that they give the pilots. And so he did that almost immediately. And they asked him why, and he was like, well, I knew I was going to need certain components of the aircraft that need the APU, so he turned it on as one of the first things. So again, expertise. Taking control of the airplane. So it turns out that the co-pilot was flying the aircraft. He immediately requested control of the aircraft. And you might think that the reason was, well, he's the pilot. He wanted to sort of be in control. And it wasn't actually so much that. It turns out that he had been flying gliders most of his career. And so he had a lot of knowledge about managing energy when you don't have engines, right, in an aircraft. But the other thing is that he had about 5,000 hours in this particular aircraft. So he was relatively seasoned in the way that the aircraft works and handles, in ways that you might not get in training. It turns out that the first officer, this was his first flight out of training for the A320, flying this type of aircraft. He had a lot of experience as a pilot, but first time flying the A320. The reason he gave him the checklist to run, because he had just passed a check ride. And so he was very fresh on the documentation and sort of what the book says you're supposed to do. So he split those tasks up. And he knew to do that because he had this expertise in this area about crew resource management. One of the last things, he didn't attempt to land back at the airport. As a private pilot, they always teach you to do that. They did a number of simulations. If had he done that, had he followed that advice, he would have crashed into the city somewhere, and that would have been unpleasant. So this is what expertise looks like in aviation. And of course, we all know what expertise looks like in operations. This is 10,000 hours worth of expertise. Okay, so how do you transform experience into expertise? How do you do this? Well, Hoffman and Klein go on to sort of describe ways that you can do this. So personal experiences, the opportunity to be continually challenged, directed experiences. And the interesting thing about this is receiving tutoring, it's not actually about getting the tutoring. It's about getting enough tutoring so that you can be a good tutor to someone else. That's what makes sort of this idea of expertise, right? That you have enough sort of mentorship that you know what a good mentor looks like in the domain. And you can do that with people that need mentoring. Manufactured experiences, so the training simulation, and then vicarious experiences. Again, painful memories. So what does this look like in operations? Personal experiences, this is sort of on-call. And by the way, it's not 10,000 hours of just being on call. It's about being challenged over and over again in new and novel, interesting, different ways. So that's why I say, for us on-call, if we've all been on-call, we often get challenged in weird, wacky, fun, new ways. Well, they're fun in retrospect. They're not fun at 3 a.m. But that's what makes it useful experience. So training, code review, we've had a lot of talks here about how to mentor engineers, and I think that's really great. That's how that factors into why it's useful. It not only makes them better, it makes us better when we do that, when we play that role. Chaos engineering game days, again, a lot of just really interesting discussion about that here. And then vicarious experiences, those are the things, the stories you're all telling each other out in the hallway track, right? And of course, it was DNS, right? But these war stories that we trade with each other, there's things that, again, are sort of, I was going to say leave a mark on our career, but maybe almost leave a mark on our soul, right? And we tell these stories over again, campfire type stories. The second, so that's the first way we can sort of get better at this. The second way is exploring discretionary spaces. So if you were here for Barron's talk, he talked about the Rasmussen triangle. I'll go through it very quickly, but I have a different take on it than he did, so it's not going to be exactly the same. So if you weren't here, the idea is you've got these boundaries. There's an economic failure boundary, an unacceptable workload boundary, and then sort of an unacceptable risk boundary. And so this is the idea, right, that if you cross the economic boundary, it becomes too expensive, so we wouldn't do it, right, because we'd either be out of business or the project would be shut down. The unacceptable workload, one of the ways to parse that is human evolution. We want the most bang for our buck cognitively out of each gram of sugar that we burn, so we are lazy, right? And it's not an insult. It's just we try to be as efficient as we can be in the whatever work we're doing, and we find naturally, we don't even think about it. We find shortcuts and ways to get better at doing that work. That's what that is. And then finally, the acceptable or unacceptable risk boundary. That's what we would call an incident or an accident, right? So Rasmussen had what he called them pressure gradients. So the business is constantly pushing that way. So this is the idea, cheaper, better, faster, right? The business wants that. We, sort of in the trenches doing the work, we want max work or max value for the least amount of effort. So we're pushing this way. Where are we all happily pushing the system? What boundary are we pushing it towards, right? So in Rasmussen's model, there was this idea that these boundaries are kind of shifting and moving, and there's this sort of dotted line. And in the picture that Barron, and I didn't put it on here, but the picture Barron had and the one that's in the paper talks about the margin of error, right? And that's that between the dotted line and the solid line. And so his Rasmussen's point was, this is what we call the discretionary space. And organizations that are really good at incident response and not having a lot of incidents that customers notice, explore this entire space. They get really good at finding where that dotted line is and pulling the system back, or getting really good at starting to detect where that edge is. They're so good at it that things that are incidents for them, we as customers don't notice. And that's why we think they're awesome and amazing. It's not that they don't have incidents, it's that we don't notice them because they've gotten really good at exploring that discretionary space. So there's this book from Google on SRE, which I don't know if you've heard about it. But I took this right from there. And so this is the reason, right, that if you look at that sort of Maslow's SRE hierarchy, that's why postmortem and incident analysis and incident response and postmortem and analysis are so based to this. Because this is the way that we get better at operating our systems, is going through the experience and building up this expertise. Now, one of the important points I want to make is a lot of times people say, why do you hold a postmortem? And people will say, oh, well, we do it so we can fix the problem. so we can get JIRA tickets and then fix the problem, right? Well, Etsy, when they hold a postmortem, they only ask 2 questions. Did one person learn, at least one person learn something that will change how they do work in the future? And did half the attendees say that they would attend another debrief? So I want to give you that perspective that it's actually not about remediation items when you do a retro. So, pulling this all together, I asked earlier, how do you get better at knowing what to do when an incident is occurring? And the answer is, create space and experience to facilitate the cultivation of ourselves and our team so as to improve our collective heuristics at detecting weak signals and ambiguity in the complex socio-technical systems we operate and in which we exist. Or another way to say that, practice makes better. It does not make perfect, it makes better. This idea of expertise, us becoming experts, takes time and space. And you need to create time and space in your organizations to cultivate that. That's where it comes from. And finally, it's just us out here. This is a picture from Voyager 1. And NASA told it to turn itself around and take a picture as it was leaving our solar system. That dot is us, right? And there's a famous Carl Sagan quote, look again at the dot, that's here, that's home, that's us. In the chaos of our day-to-day work life and incidents and trying to keep the site up and deploying new features, it's just us out here. So we need to be good to each other on our journey to expertise. And we need to do that together. Thanks. So I think we have 4 minutes for questions. Any questions? I saw somebody put their hand up when I mentioned Cactus 1549, so I kind of want to know what now I want to know what the question was, but.
Not a question, but a comment.
Yeah.
The point about, do you wait for the test to pass?
Yeah.
I hesitated. The reason I hesitated is because in my head, that's a rollback, right? The thing that I should be doing is a rollback, and a rollback is rolling back to a previously tested state. And so that's the distinction, right? A fix forward to me is a different thing, and that was just something I thought was interesting in my thought process.
Right, yeah, so this is an interesting thing. This becomes sort of a heuristic language cognitive thing. And you find this if you talk to teams. What you consider a rollback, somebody else might not on your team in the same context. So the point is, that's actually interesting if that goes bad and you talk about it. Those are juicy nuggets.
On the topic of change, it's one of the things people look at right away. Oftentimes, it's a change that was made 3 days ago, 4 days ago, 5 days ago, and people say, wow, the change was made 5 days ago, so it can't be that. And then, of course, it's always that change.
It's DNS.
How do you, yeah, exactly. How do you accommodate? I mean, obviously, as an expert, you accommodate for that, but how do you train people to identify, maybe it's gut instinct or hunch, but.
That's the thing, is that I think you hit the nail on the head. When we're working in a system and our context for that system, those things start to become hunches or what have you, because I've heard people say we work in complex systems. So this whole causation correlation, we could have a whole philosophical debate on that about I made the change 3 days ago. But you've had this, I'm sure, too, where I made the change 3 days ago, but then some subtle other normal thing came along that always happens, and it was those two things, right? So that's where that L1 cache comes in. And I know that because I work at Etsy and because I have this specific monolith or microservice or whatever it is, I know to look for those things, and I don't even have to necessarily trace it back in the moment when I'm responding to the outage. So I think you kind of hit the nail on the head. You actually want to foster that hunch or gut feeling. Yeah. Cool. Any last question? Get one? No? Cool. All right. Thank you.